42, the number of smallest unoccupied chair. So let's first try to understand the problem, and then we're gonna think about which kind of approach we're gonna use to solve the problem. So there is a party, so where n friends numbered from 0 to n minus 1 are attending. So this means, yeah, so there's a party, so we're gonna have the friend of 0 to n minus 1. So this is what we are giving. And there is an infinite number of chairs, so this is an infinite number of chairs, so it means all the friends can take in on those kind of chairs. So when a friend arrives at the party, they sit on the unoccupied chair with the smallest number. Yeah, so what's gonna be the smallest number? So the smallest chair number gonna be starting from 0 to maybe, yeah, we don't know, maybe n minus 1, because there are n persons. So all the chair numbers may be just coming from 0 to n minus 1. So for the first person, so for example, if this is a person 0, maybe this guy gonna sit the smallest chair, so it's gonna be 0. Yeah. So for example, we have 0, 1, 5 unoccupied. So 0, 1, 5. Let's just use this example. Yeah. So 0, 1, 5 is occupied currently. Yeah. And when a friend comes, they will sit on the chair number 2. Yeah. So this is because 0 and 1 is occupied, so definitely this guy will sit on this chair with number 2. Yeah. So when a friend leaves this party, their chair becomes unoccupied. So for example, if this friend 2 leaves the party, yeah, so this chair 2 will become unoccupied. So we are giving a 0 index to the array. The times I means arrival I and leaving I. So indicating the arrival and leaving time of the ith friend respectively, and integer target friend. So what is the target friend? It is just an integer. Yeah. All arrival times are distinct. So all those arrival times, so this is for 3, like here, yeah, this 1, this 2, and this 4, all the arrival times are distinct. Yeah. So we're gonna return the chair number that friend number the target friend will sit on. Yeah. So what does this mean? We're gonna return a chair number. For example, the target friend is 1, and the friend number the target friend, and which friend number the target friend? So it is this friend. Yeah. So this friend is 0, this friend is 1. Yeah. So basically we are checking this friend. So we're gonna return the chair number that the friend number the target friend will sit on. Yeah. So let's just try to understand it from here. So friend 0 arrives at time 1. So this is a friend 0. Friend is just the index. Yeah. So arrive at time 1 and sits on chair 0. So 0 is occupied. And then friend 1 arrives at time 2. So this is a friend 1 arrives at time 2. Yeah. So now the friend 1 will sit on chair 1. So the chair 1 is occupied. And what is our target friend? Our target friend is friend 1. So this means we're gonna return this number 1. Yeah. So we're gonna return the chair number. Maybe this is very confusing. Let's just make it simple to understand what is the meaning. So currently we are having this kind of infinite chair. It is numbered from 0 to n minus 1, but this is unoccupied. Yeah. So currently I have a friend, so I will occupy 0, and I have another friend, I will occupy 1, 2, 3, for example. Yeah. Now what happens is this friend will leave at this time. So this number 2 will be cleared. Yeah. And next we have another friend, and this friend will sit on the number 2. So it will sit on here. It will use this number 2 because it will always choose the smallest number of the seat. So for example, the seat have a number, it will choose this number. And what we are going to return? We are going to, yeah, return the chair number that the friend number the target friend will sit on. So for example, this is our current target friend. Now it will sit on this chair, so this chair is number 2, so we're gonna return this number 2. Yeah, so this is what we are giving. Yeah, because we don't know if this is the arrival time for my current person. I don't know if this is a target friend or not, but it doesn't matter. So if this is maybe this is just my my target friend, so this is my arriving time. So at this arriving time, what time I need to know? Because this is the arriving time. Definitely, I want to choose a seat number to sit on, but I don't know what gonna be the smallest chair number. How can I find what gonna be the smallest chair number? Yeah. So we're gonna store all the empty chairs inside an array, because at each of the time we're gonna need the smallest chair number. So this means we're gonna need a priority queue, and we're gonna use this priority queue to store the smallest chair number. So for example, we're gonna store from 0, 1, etc. until maybe n-1. So this priority queue means all those chair numbers is empty. It means it can be taken by anybody. Now it comes to this friend. Maybe it equal to the target friend. Yeah, it can be equal to the target friend. For example, target friend is 1. So this is a running time for this target friend. So how can I find which seat number I will take in? So if this is the priority queue, and definitely I will store all the empty chair numbers, I just pop out. It should be okay. But before I pop it out, I don't know which chair number has already been taken. So for example, this one has already been taken, so this one will be cleared. It means there will be no one. But how can we find this one? So this one actually is determined by all the leaving time before this A. So for example, this is my leaving time, this is my leaving time, and this is my leaving time. And here maybe I have another leaving time. I don't care about the arrival time, I just care about the leaving time. Yeah. So if this leaving time is smaller and equal than my current arriving time. Yeah. So this means all those chair numbers will be cleared. So for example, maybe 1 is inside, or 2 is inside, then my priority queue will be 0, 3, and all others. And what I gonna return, I just pop out the priority queue, and 0 gonna be my answer. Yeah, so this is the idea. So for my target friend, if it comes to the target friend, I will check all the leaving time, which is smaller and less than my current arriving time, and all those seat numbers will be cleared from the priority queue. Yeah, but how can I find all those chair numbers which gonna be less than and equal to, yeah, less than and equal to my current current arriving time? Yeah, basically this means I'm gonna prepare another array which gonna store the leaving time. So for example, this L is the leaving time, maybe yeah, maybe the leaving time is 4, and maybe this leaving time is 5. Yeah, and for each of the time, I'm gonna check all the leaving time which is less than or equal to my arriving time. And what kind of data structure I can use to check that? Basically, it is another priority queue. It's gonna be a min heap. So I'm gonna choose the smallest leaving time. If this is less than or equal to my arriving time, yeah, basically I need to, what I need to do, I need to pop all those leaving time out. Yeah, because it means the leaving time is cleared, and all those chairs will be pushed back into my priority queue again. Yeah, because it means this body leaves this chair, so this chair is empty, so it will go back into the priority queue. Yeah, but how can I find the? So this is just a leaving time. How can I find which chair number it is? Basically, I need to use an index. Yeah, so for example, this 4 with an index, this 5 with another index as a tuple. So the leaving time with index, basically, I know, oh, it is at this chair there's going to be a living time. So this means for the living time, or I call it used array, it means the chair is taken. I need the living time and the chair number, so it's going to be the index. Yeah. Now let's just try to unsolve it. If you understand the basic problem, if you understand what kind of approach we're going to use, basically we're going to use a two priority queue. One priority queue is empty chair. It means all the chairs are going to be empty. It's going to be inside of the priority queue. Another chair is called used array. It means all those used chairs will be put inside of the used array. Yeah, and we're going to solve it by using two priority queue. Yeah, now let's just try to unsolve it. So let's just prepare the length of the times is so this also means how many chairs we're gonna have. Yeah, now we're gonna prepare an empty chair. So I gonna call it empty chair array. So inside it's gonna be a list of rings from A. Yeah. So this means from the beginning, all those chairs will become empty. Why it is n? Because it is the length of the times array. So basically, the times array, it is numbered from 0 to n minus 1. So basically, it means that there are going to be n chairs, and those n chairs will be empty. So this is why I'm going to prepare this empty chair array. Now we're going to update this times array. For this times array, basically we're going to prepare a tuple. It's going to be the arrival time and leaving time and an index. So for I arrival, leaving, in enumerate the times array. Yeah, because basically I need this kind of times array. It's going to be a tuple. Inside it's going to be arrival, leaving, and index. And the index is the chair number, which is very important for me to find which is going to be the target friend. Yeah, because if target friend is 1, it means this index is going to be 1. So this index is used to find the this index is used to find the target friend. So for example, this is a friend 0, 1, and 2. I'm sorry, it is not the chair number, it is the target friend. So this index. Now we're gonna sort the times array according to the arrival time, and we're gonna use another array which is gonna be used. So this used gonna be a tuple, and inside it's gonna be the leaving time and the index. I'm gonna call it so I'm gonna call it index. So now what we're gonna do, we're gonna just loop through the times array. So for arrival, leaving, and index I inside the times array, I'm gonna check the used array. So while there's something inside of the used array, it means this is occupied. This here is occupied, and used 0, 0 is the leaving time. If this leaving time is less than or equal to the arrival time, so basically, what I'm gonna do, I'm gonna just pop out the used array. So I'm gonna use a heap pop. It's gonna be the used array, and it's gonna pop out the two values. Yeah. So it's gonna be, I'm gonna call it leave and index. So I'm gonna pop out the leave time, and basically let me think about it. I just needed to pop it out. Yeah, I'm gonna pop out a leave time and index from the used array, and then I'm gonna use heap push. Yeah, because basically this means this chair is empty. If it is empty, I want to put it inside of the empty chair array. So it's gonna be empty chair, and I need this this index, and this index is also the chair number, because the chair number is from 0 to n minus 1. Currently I'm gonna just push this chair number. So this index is actually the chair number. Maybe let me put it here. It's gonna be the chair number. Yeah, maybe here I can also use chair number. So let me just use chair number. Yeah, now I want to put it inside the empty chair array because this chair number is really important because I want to know the smallest chair number. Yeah. Now, what I gonna do? So currently it means, yeah, if every, let me make the drawing again. This is my current arrival time. Yeah, if all the leaving time is less than or equal, so this means I gonna pop out from the user array and I'm gonna push it to the empty chair array. So this means everything will be inside the empty chair array. So now I should know my current chair number. So I'm gonna call it current chair number. So my current chair number gonna be heap pop, which gonna be the empty chair array. Yeah. Now what I gonna do? I'm gonna check this current chair number if this is equal to my target friend. Yeah, I should not call it the current chair number because it is not chair number. Maybe let me just call it index. So this index is actually the target friend number. Let me just call it index. Yeah, so this index is the target friend. Yeah, let me call it friend maybe. Yeah, let me call it friend number maybe. Yeah, let me just call it friend. Sometimes it's really difficult to find a right variable name. Yeah, so let me just call it friend. So this means this is the leave time for this friend. So this friend will be put into the empty chair. Yeah. Now I have my current friend. So if this current friend equal to the target friend, so this means I can yeah, so this means I can return what we're gonna return. So we're gonna return the chair number. So the chair number gonna be this index I. Here this user array inside it is the friend. Let me just call it friend. And here this I is the chair number. Yeah, let me call it chair number. So currently, if this current equal to the target friend, it means I find this person. So basically, I need to return the chair number, and this gonna be my current chair number. Yeah. So otherwise, I'm gonna put it inside. So it's gonna be the user array, and it's gonna be a tuple, and it's gonna be the leaving time. With my current friend. Yeah, so this current friend and the leaving time as a tuple will be pushed into the user array. So I think that's about it. Yeah, I mean there's a lot of variables. We must understand what is the meaning for each of the variables. So this is arriving time, leaving time, and the chair number, because if we enumerate it, basically it is the chair number. But here for the user array, it is the leaving time and with my current friend. So this is for example, this is a target friend. Yeah, and this target friend is also, yeah, I think I make it very confused with the chair number. So it is just a target friend. the chair number is not the same as the target friend. So this I, yeah, so this I gonna also call it yeah, let me first run it to check. This is gonna be the times.sort. Yeah, I find it really difficult to explain sometimes because there are so many variables. It didn't work for the second testing case. Yeah, let me just check it. So this is gonna be the empty chair array, and I need to heapify this array. Heapify the empty chair array, and because basically this is also a min heap, I need to heapify it, otherwise it didn't work. And the times array, and this is my used array, and this I, yeah, this I actually it is the just a friend number. Let's just call it this target. Each of the friend is gonna have a friend number. Let's just call it a friend number. And this used is also for the friend number. And we're gonna search the times. We're gonna use the used array, and then we're gonna look through the times. So while used, and this is less than or equal to the arrival. So we're gonna prepare a leave time, and with the friend number, we're gonna pop it out from the used array, and then we're gonna push it to the empty chair array for this friend. Yeah. So currently, this current gonna be, we're gonna pop it out. This gonna be the chair. Yeah. So the current gonna be a chair number. So if this equal to the target friend, I'm gonna return the, yeah, I think I did something wrong. If this index I equal to the target friend, because this index I actually it is for the friend number. If this friend number equal to the target friend, and then I'm gonna return the chair number. Yeah, this is very confusing because it has the friend has a number and the chair has a number. Yeah, so we have to be very careful about it. So here I think I did something wrong with it. So I think it's gonna be this I gonna be the friend number. Is this friend number equal to the target friend? So if this is my target friend, basically I need to return the chair number. Yeah, so let me put the chair number. So this is gonna be the chair number, and I'm gonna pop it out. It's gonna be the chair number, and here, yeah, I'm gonna just put the chair number inside of this living array, inside of the used array. So this is not a friend. This is just a chair number. I think now it should be clear. Yeah. So for used array, it is the living time with the chair number, because we're gonna check which chair is used or not. And for the times array here, this I index, basically it means the friend number. It is for which friend. Yeah. Now let me just run it. Now as you can see, it works. Yeah, because basically now we understand what we are doing. Yeah, as you can see, it's pretty fast, and basically the time complexity gonna be n log k. Maybe the length of the times array is n, yeah, 10 to the power of 4, and yeah, and for the arrival array, yeah, let's just say that's gonna be n log n time, because basically for the use array or the chair array, the maximum gonna be n. So the time complexity gonna be n log n. Thank you for watching. See you next time.